All right, everyone, we're going to go ahead and get started. So welcome everyone again to another CPTC meeting. Just a reminder, we have meetings every Tuesday at 6:30 p.m. Just to make sure everyone can hear me, right?
Yes, sir.
All right, cool. So some things to know. So next week, Claire, UFSIP president, will be presenting on hacking industrial control systems. So definitely looking forward to that one. You should definitely come to next week's meeting to learn all about industrial control systems and how to hack them. And then again, just to reiterate, any specific topics that you want to learn about in pen testing or red teaming, or maybe that you'd like to even give a future lecture on, just put it into this Google Sheet here. And I'm going to post these slides in Slack and Discord after this meeting, so you can access this link and put in any ideas that you think you'd like to learn about or maybe even teach about. So what we're going to be doing today is Active Directory hacking methods and techniques. I'm just going to be talking about the different, some of the different most popular techniques in hacking Active Directory. And then we're going to do a try hack me room called post exploitation basics. I don't think we'll have time to finish the entire room, but we're going to walk through a couple parts of it. So Active Directory hacking. So table of contents here, we're going to do like a little introduction to Active Directory. Then we're going to talk about Kerberos, and then abusing AD permissions. So an introduction to Active Directory. Let me just close this. So Active Directory, it's Microsoft's like proprietary service used for like managing permissions on a network of different resources, that being like users, groups, computers, servers, printers, etc. Active Directory is in charge of basically managing all of those things. So you'll see this a lot in like massive companies or even really small companies. So it's like Active Directory, if you ever get into red teaming and pen testing, you will without a doubt deal with Active Directory at some point in time. So it treats the resources it's talking about, like users, groups, computers, etc., as objects, and each object can like has its own permissions. And it can also inherit permissions from other objects, such as users can inherit permissions from the groups they're in and stuff like that. So that's sort of how Active Directory works. It's basically just a method of assigning permissions to different objects within the network, and those objects being, users, groups, stuff like that. And again, if there's any like questions throughout the this presentation, please like just stop me and ask, or just put it in the chat, or however you want to do it. It's kind of a length. It's like 25 slides or so it's kind of a long presentation. So I don't want to like, wait till the end for questions. And then that was something that was like that we talked about like in the very beginning. So please stop me if you're confused about anything. So let's dig into Kerberos. So what actually is Kerberos? It's an authentication protocol used most commonly in Active Directory. I would almost say exclusively, but I think it's used in like something else as well, but it's like basically if you're talking about Kerberos, it's going to be used in Active Directory. It's basically exclusive to Active Directory. The port it runs over is port 88. So if you're hacking a Windows environment and you're doing an Mmap scan on it and you see port 88 open, that means that the host that you just scanned is running Kerberos and is most likely a domain controller. And domain controller being like the server that's like running Active Directory and is in charge of basically all of the computers and resources on the entire network. So if you can get access to domain controller, you've got the keys to the kingdom there. So it authenticates users using a provided password. So basically, if you're, for example, in a company, let's say you're a company of like 1,000 employees, and let's say you have your work computer. When you log into that work computer, if it has Kerberos set up, the authentication isn't going to be happening on the physical computer that you're at. Your credentials are being sent to the domain controller using Kerberos, and then it will authenticate you, and then basically give you access to the computer. That's basically what Kerberos is doing. What Kerberos also does, it provides information in Active Directory about what privileges each user has. However, something to note here, it's an authentication protocol, not an authorization protocol. So what this means is that it doesn't check which resources or services a user can access. That's the responsibility of said resource or service. So Kerberos is in charge of saying like, yes, this person is who they say they are. They're not in charge of saying, yeah, this person can do this, or this person has access to this service as well. That's a separate thing. So Kerberos is only in charge of saying, yes, this person is who they say they are. So the components of Kerberos. So there's three main components of the authentication process. The main components are going to be the user who's attempting to authenticate to Active Directory or access a service. Then there's the application server, which is the service that the user is trying to access. And then there's the key distribution center, or the KDC, which is what Kerberos is running on and is responsible for authenticating the user and granting tickets to use the service on the application server. So Kerberos uses something called tickets, and it's what it uses for authentication and for accessing certain services that the user wants to access within Active Directory. There are two types of tickets: a ticket granting service, a TGS. It's a ticket a user can use to authenticate against a service to gain access to that service. So a service, for example, let's say maybe like a file server, for example, right? That would be a service that Active Directory can provide that you would then have to authenticate to get access to. And so you provide the service, the file server, a ticket granting service, or TGS, and then the file server will check it. And then if it's good, it will then give you access to that service. And the other type of ticket is a ticket granting ticket, or a TGT. And that's a ticket a user can use that it gives to the KDC to request a TGS. So a TGT lets you get basically ticket granting service tickets for any service it has access to, but you need the TGT first to do that. So I know that's a little bit confusing, but I have like a nice little display here, a little visual here. So we have here the user on the left. So this would be like maybe like you, for example, like as an employee. And then we have the KDC here, which is the running on the domain controller. This is the key distribution center. And then we have the AP, which is the application. This is like the service you're trying to access. And let's say the file server, for example. You want to access, company files. What you first do is that you send a request to the KDC requesting for authentication. Then it's going to send back the TGT, right? So it's going to basically, you're authenticating, and it's going to send you back the ticket granting ticket. Then you use that ticket granting ticket, you send it back to access, to get the TGS. So you give it the TGT, and then it gives you a ticket granting service. Then you use that ticket granting service you provide it to the application server, or the service you're trying to access. It will check it, and then it'll give you access. This part here, you don't have to pay attention to too much. This is like something that's doesn't actually exist on all domains, only on certain ones to make it more secure. So this part you don't have to worry about. All you have to know is that basically the user makes a request to the KDC. The KDC gives it a ticket granting ticket. Then the user uses that ticket granting ticket to send it back to the KDC, and then the KDC will send it a ticket granting service for this specific service. Why the TGT in the first place if all you're doing is seeing it? That's a great question. So it seems like this is something that's going to be happening like basically instantaneously, but it's not. So basically what you have first is you'll get to TGT, and then between like this request here and the sending it back, it's not always instantaneous. Sometimes like maybe you authenticated to Kerberos, but then you want to access multiple services. And so you need the ticket granting ticket to access. You can use a single ticket granting ticket to access multiple services. So you don't have to, if it was just one, then you have to constantly re-authenticating to the AD. So it's more efficient if they authenticate once and then use that TGT to access multiple services or to get multiple TGSs. So that's why it seems like it'd be redundant. Like, why is there like two? But that's the reason why, just for efficiency purposes. And so that way, you have the TGT and you can basically keep that and then use it to get a TGS. Yes, exactly. You stay authenticated with the TGT. So yeah, this is basically a really nice diagram showing the process of like the Kerberos authentication. So now we're going to talk about some attacks that we can use based off that. So brute forcing is the first one. So like any other authentication mechanism, Kerberos is susceptible to brute forcing. So and actually brute forcing Kerberos specifically has a few advantages over maybe brute forcing other authentication methods, like let's say like SSH, for example. So one thing is that you don't need a domain account You don't have to be like logged into a Windows box in the actual domain for you to start brute forcing. You can do it as long as you're on the network as the same as the sorry, the Active Directory domain controller. You can brute force creds. Another thing is that Kerberos pre-auth errors are not logged in Active Directory as a logon failure, basically meaning that certain types of brute forcing you can do with Kerberos will not get logged in Active Directory as a logon failure. While like other authentication methods, like if you were trying to log in as SSH and brute force that, there's going to be a ton of logs on the SSH server saying you just had like 1,000 login failures. However, with Kerberos, certain types of brute forcing with Kerberos won't log that as a login failure, which is really handy for us to avoid detection. And then another thing is that a great thing actually is Kerberos will tell you if the username was correct or not, even if the password is wrong. So this is really handy if you want to like enumerate like a bunch of like see what usernames exist on an environment. You can basically just throw it at it, and the password doesn't have to be correct, and it'll tell you if it's right or not. That's something to also keep in mind when doing when you're brute forcing Kerberos. So some tools, brute forcing tools. There's a Python tool called kerbrute.py, and then also an executable called Rubius. You're going to see Rubius a lot in the recommendations for future tools in this lecture, because it has like basically everything related to Kerberos hacking. So Rubius is definitely probably like the tool that has it all, but Kerberos is also a really good option as well. So now, it's kind of cut off there, but I'll just try to talk. All right, cool. So now we're gonna talk about some like what passing you can do, some pass the blank attacks. So the first one is called pass the hash or pass the key in Kerberos case. So if you're able to get the hash of a user, that being like the hashed password, you can use that hash to impersonate that user and authenticate to Kerberos. So you don't even have to crack the hash. You can just use that to authenticate to Kerberos. And this will allow you to retrieve a TGT and subsequent TGSs to gain access to services as that user that you don't even have to crack, and you don't even have to crack the hash. So I'll go back to my drawing here. So what's happening here in this initial request, the first request here, is that the user is sending the request along with its hashed password, right? The hash of its password, not the plain text, just a hash. And then the main controller is going to use that hash to authenticate it. And so if we were able to somehow steal this user's hash, we can then just send the same exact request. And we don't have to know their actual plain text password. So that's something that's really cool. So back to here. And so some ways that user hashes can be retrieved. There's a lot of different ways, but some common ways is from the SAM files on the workstation. So that's where basically on most Windows machines, that's where your hashes are going to be stored for your password. Or from dumping the LSASS process memory using a tool like Mimikatz. The LSASS process memory is in charge of a lot of like authentication stuff, and so it's always running. So if you're able to dump that, it's going to contain it can likely contain a lot of either maybe even plain text passwords, but certainly hashes for a lot of users that have logged into that workstation. And there's a tool called Mimikatz that can help you do that. It's super useful tool, very popular. So another attack is called pass the ticket. So basically, you can also impersonate the user if you have their ticket. So either the TGS or the TGT. So if we go back to our slides here. So if somehow during this process, right, after the user's gotten a TGT, let's say you're able to steal their TGT or the TGS, then what that basically means is that you can use that to access certain services. So for example, now something to keep in mind is that it's definitely better to have a TGT than a TGS, right? And so the reason for that is basically what I've been saying, is that a TGS will only grant you access to a specific service, but a TGT you can use to get multiple TGSs for multiple different services. So if you were able to steal someone's TGS, that's good. It means you can access that one specific service, which definitely is handy. But if you have a TGT, it's much better, because that means you can access basically any other service and grab, request a TGS for each of those services. So tickets can be stolen through man-in-the-middle attacks, but it's not super common, and it doesn't contain the entire ticket because of the way it encrypts it. But the more common way is through dumping the LSAS process memory, like I was saying before, using a tool like Mimikatz. So LSAS process memory not only has hashes, but it can also have TGT and TGS tickets as well. So something to definitely keep in mind is that the LSAS process memory has a lot of valuable stuff that you want to look at. Something else to know is that tickets have an expiration time of about 10 hours by default. So definitely keep that in mind, that once you steal a ticket, you can use it for about 10 hours before it expires. Okay. So again, some tools for that. For pass the hash, there's get_tgt.py and of course Rubius. And then pass the ticket, Mimikatz, and Rubius again. Again, you'll notice a trend that Rubius has a lot of tools. Thing responder can be used to man-in-the-middle for Kerberos. Yes, that is true. The only thing with that, so if we go back, is that it won't contain the entire ticket. You're going to have to also crack the hash in that case. But yes, you are right that you can do a man-in-the-middle attack to get the ticket, but you also have to have the cracked hash of the user that's associated with that ticket to actually make it useful. All right, so now we'll talk about some gold and silver attacks. So the golden ticket. So golden ticket involves forging your own TGT to be used against Kerberos to retrieve TGS tickets for any service in the domain. So it sounds similar to stealing a TGT, but the difference is you're not even stealing one, you're just creating your own. In order to create your own, though, you have to have the NTLM hash of the KRB TGT account, which only exists on the domain controller. Sorry. What this account is, is associated with Kerberos. So if you've gotten access to the domain controller, and you have a local admin on the domain controller, then you can dump the hash of the KRB TGT account and use that to forge your own TGT. And basically, once you have that, now you can request TGSs for any service on the domain. So that's something that's really useful. And something I should specify is that when I say service, I'm using that in a very broad sense. A service can be almost any sort of functionality that you could think of in a Windows environment, like creating users, creating groups. Those are all technically services that can be granted through TGTs and TGSs. So that's what I mean by service. Very, very broad term. So now silver tickets. Silver tickets are similar to golden tickets, except you're forging your own TGS instead of a TGT, and it can be used against the service you want to gain access to. So like I was saying before, if you forge your own TGS, it can only be used against that service that you're forging it for. So it's not as much access as a golden ticket, obviously, because a golden ticket, you have a TGT and you can request as many TGSs as you want. But with silver ticket, you're only forging a single TGS for a single service. And again, this requires the cracked NTLM hash of a valid TGS, which can be stolen using an attack called Kerberosing, which we'll get into. But just to go back here, so similar with pass the ticket, how you have to steal a TGS first. That's a similar thing with silver ticket, is that you have to have a valid one first. You'd crack it, and then you could use it to basically forge your own for potentially other services as well. So yeah. So now some tools. For silver ticket, we have ticketer.py, Mimikatz again, and of course Rubius. And then golden ticket is exactly the same. Ticketer.py, Mimikatz, and Rubius are all great tools for performing silver ticket and golden ticket attacks. Something to note here is that golden ticket, you have to have a local admin on the domain controller, which is the keys to the kingdom for that. So that's why I called the golden ticket, because it's it's the ticket, but you can only really get that once you've compromised the domain controller. So roasting, there are two roastings here. I'm going to move this over here. Okay, so there's curb roasting, which involves requesting TGS tickets for a service, and the TGS tickets are encrypted with the NTLM hash of the user account that is running the service, and then you would use that to then crack it offline. So a good thing about this is only a normal domain account is needed to get a TGS for a service. Um, and but only user accounts that have a service principal name attribute set are vulnerable to Kerberoasting. So talking about the file server analogy again, if you had a file server that you wanted to access, you would request a TGS ticket for that service, and it's going to come back, which is going to be encrypted with the NTLM hash of the user account that's running that file server, right? And then if you're lucky and the account that's running that file server has a really weak password, right, like password 123 or like something you could crack, then you could crack the TGS offline, and now you basically have the password for that account, and you could use it to maybe log into that account or do some other things. But that only work if that file server account has this attribute set, service principal name, which is more common than you think. So basically how it works is you first request TGS for service of a service account that has this set. Then you would dump the ticket using Mimikatz once you retrieve it, and then transfer the ticket to your local machine for cracking. So that's basically how Kerberoasting works. But it does require you to have a domain a domain account on the environment. You can't just be You can't just be within the network. You have to actually have already like at least compromised a single workstation in the Active Directory environment. And then there's AS rep roasting. So AS rep roasting, like it involves retrieving the password hashes of user accounts to be cracked offline, similar to Kerberoasting, except it basically will. It's part of it takes place in a different process or a different step in the Kerberos authentication process. So if we go back to the picture here, so where the Kerberoasting process occurs would be in something like here, for example, or in this step here. Where AS rep roasting occurs is in this step here, is in the carry at the very first request. So if we go back, so basically you send a KRB as request that contains the username of the account, but not the password. So basically, if you know the usernames, which you could have found out by doing Kerberos brute forcing, like we were talking about before, you can get a list of usernames. Let's say you know the usernames, but you don't know the password. So you then send the KRB as request message that contains the username of the account, but obviously not the password since you obviously don't know it yet. Then the KDC will respond with a response message. It's going to be encrypted with that user's NTLM hash that you provided, the username. It's going to encrypt it with the hash. Then you can use that. You can use the message it gave you you basically crack it and obtain the user's password. So this is only possible if user accounts have the do not require Kerberos pre-authentication attributes set. Those are the only ones that are vulnerable by AS rep roasting, which again is more common than you think. So that's definitely something to look out for. Is basically you first maybe try Kerberos brute forcing to get a list of usernames. Then you try to do AS rep roasting with those lists of usernames to see if you can get any hashes from that. And basically you then crack those hashes. So some roasting tools, Impackets get users spns.py. It's a really good tool. Impacket in general, if you look it up on GitHub, has a great selection of tools that all involve like Windows and Active Directory hacking. Definitely recommend looking into that if you're interested in this kind of stuff. And then of course Rubius, because Rubius basically is a one tool that does all. And then again, AS rep roasting, Impackets get npusers.py, and of course Rubius again. All right, so now we're going to talk about abusing AD permissions. Just to make sure, are there any questions about what I just talked about? Because now we're done with Kerberos now. If anyone has any questions about that, if you probably want to ask now. You can ask at the end, but probably easier if you just ask now. Okay, if not, then we will move on. Abusing AD permissions. So what are Active Directory permissions? So I talked a little bit before when introducing Active Directory. That's basically it treats resources as objects, and those objects then have permissions for what you can do with it. So those objects are like using groups, and then these objects can be secured by setting permissions on those objects. So Active Directory defines these permissions in something called a DACL, which stands for Discretionary Access Control List, which will contain information on who can read, modify those objects, etc., such as like changing usernames, resetting passwords, stuff like that. That's what a DACL will contain. It'll basically have you a list of permissions on that on the object of what it can and can't do. However, if configured incorrectly, attackers can abuse these permissions to gain higher privileged access to the domain. So that's what we're looking to right now is abusing misconfigured DACLs, essentially. So what kind of, as a red teamer or as a hacker, what kind of permissions are we looking for that could give us more permissions, right? So some are generic all, which basically means total control of the object. So if the object is a group, we can add users to that group. And if it's user, we can reset that user's password. So if you've compromised a Windows host in an environment and you're trying to find ways to escalate your privileges, right? And then you check your DACL permissions and you see that you have generic all on like another user, then that means you have the permissions to change that user's password. That means you can change that user's password and then just log in as that user. Or if you have a generic all on a group, then you can add a user to that group with a password, and then you can just log in as a user, and now you're in that group. Another permission is called generic write, which means you can update the object's attributes, such as logon script path, which means like essentially, so certain objects have attributes. One of those attributes are called a logon script path. So basically it means like you can specify an executable to run every time that object logs in, if that object is a user, for example. So if we point that logon script path to our own malicious executable, right, that means the next time the user logs in, our malicious file is going to get executed. And that malicious file can be like, reverse shell, for example. And now we have just escalated our privileges and become that user that just logged in. So that's something that's like really useful. So generic all, generic write are something that you really want to look for. The next permission is write owner, which means we can change the object's owner to ourselves. And so then we now have full control of the object. So basically, if you see that you have write owner permissions of another user, that means you can then execute a command to change the owner of that object to yourself. And now you have generic all permissions of that user. And then once you have generic all, like I was saying before, you can reset the user's password, etc. So essentially, if you have write owner, it's basically just one step, and then you have generic all. And now there's write DACL, which is a similar idea. So it means we can modify an object's DACL and give ourselves full control of the object. So basically, if we have write DACL against another user, we can change that object's permissions and then give ourselves generic all permissions, and then do what we were saying. Another one is all extended rights, which is pretty much the same thing to generic all. You have the same kind of permissions. So if you see that, just equate it to generic all. Then you have force change password, which means you can specifically change that user's password, and it won't like prompt you like to re-enter the old password. So if you have force change password permissions on another user, you can just change that user's password and log in as them. And then there's self. It's called a self permission, and that means we can add ourselves to a group. So if you see you have self permissions on another group that you're not currently a part of, you can then add yourself to that group. So these are some of the most common DACL permissions that you want to be looking for when looking to escalate your privileges within an Active Directory environment. So now I'm going to talk about a pretty useful tool that will help you do all that. So you could do all that manually, finding all the permissions that exist for each object, users, and groups in the Active Directory environment using like PowerShell. PowerShell will let you do that, but it'd be very tedious to list out like all the permissions and all the DACLs for each object inside the environment. So Bloodhound is a nice tool that allows you to easily visualize the relationships within an AD environment, specifically relationships that we can abuse to escalate our privileges. So by relationships, I'm talking about like the permissions that we have on other objects, and also what permissions those objects have on other objects, and so on and so forth. So it's like a whole little like map of basically what has permissions against what. And Bloodhound itself is a web application that's run on your local machine, like on your local Kali instance. And then it has a companion tool called SharpHound, which is actually what gets run on the workstation that you have control over inside the domain. And that's the tool that's going to like collect all the relationship data and all the permission data. And it's going to basically output into a nice little JSON file. We transfer that JSON file over into Bloodhound, and Bloodhound has a very nice display for displaying all the relationships that objects have to each other, and also it'll display the potential attack path you could use to eventually work your way up to domain admin. So nice little picture here, a very simple example of what Bloodhound would look like. So after you run SharpHound and then transfer that file into Bloodhound, you might see something like this. So let's say this user here in the top left is our current user, the user that ran SharpHound. Now, Bloodhound found out that we are the admin to this computer here, which is called DC01 offense.local. And then in this computer has a session connected to it of the administrator, right? And this administrator is, of course, a part of the domain admins. So this is sort of showing you an example of what Bloodhound's able to find for a potential path to all the way to the domain admin just from a low privilege user. Because if you are admin of this box, you can, and there's a session, administrator has a session connected to this box, maybe you can dump LSAS process memory, and maybe it'll dump the creds of the administrator, since the administrator is currently logged into this machine. And once you have the creds of the administrator, then you can just log right into the domain admin. So Bloodhound's a really nice tool for helping you visualize that and like suggesting the quickest and best possible path to the domain admin from your current low privilege user. Okay. So are there any questions on any of those Active Directory permissions or anything like that? If I went too fast, went too slow. Okay. If not, then so here's some boxes that I recommend that if you guys want to like practice more of the Active Directory stuff. For Hack the Box, there's the Forest, Sauna, Active, Resolute, and Cascade are all really great boxes. I think about half of these are active right now, and the other half are retired. So you have to have a VIP account. But UF does have Hack the Box VIP accounts. So if you want to work on one of those, just send me a DM in Slack or Discord, and I can give you the credits for that, and you can work on one of the retired boxes. For Try Hack Me, there's a few rooms that are really useful, and one of them we're actually going to do in a moment. There's Attactive Directory, Active Directory Basics, Post-Exploitation Basics, which is what we're going to be doing, and then Attacking Kerberos, which is also another really good one. I think one or two of these you have to have a Try Hack Me VIP account, which our club unfortunately does not have ones to give away. But most of them I think are just free. You just need an account for Try Hack Me. Question, but how did AD get swapped? That's a good question. I would say Microsoft being dominant in terms of just making Windows computers in general. It probably came installed with, like the big, I guess the main servers came installed with Active Directory, and there was no one else really to compete. If I had to guess, just because Microsoft has such a monopoly in that kind of stuff, they didn't really stand much of a chance. That's why I would say Active Directory came to play, and it's also it's very good. They made it very well. That's probably the main reasons. Okay, so these are the references I use. Again, I'll post this all in Slack and Discord. If you want to dig deep into this and read more about it, there's also a nice little cheat sheet here for Kerberos hacking. But yeah, thank you guys. And then we're going to go ahead and get started on the Try Hack Me box. So what was this? Okay. Let me, if anyone has any questions while I'm getting set up here, or if you guys don't have does anyone not have like a Kali box or needs help getting some sort of Kali box set up? Connor's right. AD is Windows. Okay. Share my screen. Can you guys see my screen here? Cool. Okay, so for this room, you basically want to log into TryHackMe, go to Hacktivities, and then just do a search for post exploitation basics. It's gonna be this guy here with the little kiwi. And then there's a lot of different tasks. We're probably going to get through maybe 2 of them or so, and then I encourage you guys to work on the rest on your own, because they're like these ones, like digging the Mimikatz and then enumerating the server manager, maintaining access, etc. But we're probably going to look into just Power View and then Bloodhound for now, and maybe Mimikatz if we have time. Does anyone not have access to TryHackMe or is having issues getting to this? Basically just want to join the room and then hit deploy. All right, so I go ahead and get my box set up here. And if anyone's having like trouble setting up the OpenVPN or getting connected to it, just let me know. Okay, so we've got an IP here. Let's go ahead and start the box, I guess. This room will cover all the basics of post-exploitation, enumeration, Power View, Bloodhound, dumping hashes, golden ticket, attacking Mimikatz, basic information gathering using Windows server tools and logs. Cool. So deploy the machine, we've done that. Next tasks. To start this room, you'll need to RDP access to the machine with your credentials. So go ahead and do that. So this, obviously, by the tell with the name of this box, this room assumes you already have compromised a Windows machine on the network. So we'll go ahead and SSH here into users administrator at 10.10.198.194.
You put one too many 10s.
Oh, thank you for telling me that. That's why it's taking so long. There we go. Connection reset. Okay, here we go. Okay, don't know why I'm getting password wrong. Password 123. Okay, was anyone else able to log in? I spell administrator wrong. Administrator. Maybe it has to be a lowercase a. Okay, that's not working. Oh, maybe I have to do. Okay, I think I see. I have to do controller.local. Nope. Huh. I mean, we could RDP in, but that's a pain. Oh, it's 123 at. Okay, I was reading that like so weird. Okay, there we go. I don't know why I read that like it was like some sort of SSH connection. Okay, cool. So we now are logged into the box. We have a shell on it. So PowerView is a powerful PowerShell script from PowerShell Empire that can be used for enumerating a domain after you've already gained a shell in the system. We focus on how to start it up, get using groups from PowerView. I've already taken time to put PowerView on the machine. Awesome. So let's start PowerShell. PowerShell EP bypass, which it says here, it's going to bypass the execution poly of PowerShell, allowing you to easily run scripts. So now we have, I can see by PS here, we are now in a PowerShell instance. So we'll go ahead and start PowerView. Downloads, PowerView, PS1. Cool. And now we're going to enumerate some users. Get net user, select CN. So these are a list of users that it's found. Administrator guest, KRB TTT, we talked about before, was the Kerberos related account. We have machine 1, admin 2, machine 2, SQL service, post. I'm guessing this is a flag. So we'll have to remember that. And then an SSH user, which makes sense because we're SSH into the box. It makes sense that it has a service account related to it. Right. Enumerate the domain groups now. So get group name admin. So these are all groups that have the word admin in it. So we got administrators, Hyper-V administrators, storage replica administrators, schema admins, enterprise admins, domain admins, key admins, enterprise key admins, and DNS admins. A whole lot of admin groups. So now let's now enumerate the domain further on your own. Okay, so what is a shared folder that is not set by default? So let's, I guess, open the cheat sheet and see. Question was, what is the shared folder that is not set by default? So I'm sort of doing this in real time just to show you guys, like, that's my thought process going through this kind of stuff. But whoever finds it first, you guys can just say it in the chat and say how you found it, just so you're not just like watching me do everything. So what is the shared folder that is not set by default? So let's start to enumerate some shared folders then. There's a lot here. Let's try to see if we can find. What is a shared folder that is not set by default? So let's go here. Kind of like get SMB share more. Not by default. I want to say it's probably share. All right, awesome. So we found a non-default share called share. It's in C:\share, which is not a common directory. What operating system is running inside of the network besides Windows Server 2019? So let's go back to our cheat sheet here. Inside of the network besides Windows Server 2019.